Here's another sample how to design functions problem. In this problem, we're going to see a few extra wrinkles, including an example of how not to write a good purpose, some problems that can come up with tests, and some issues having to do with copying part of what's in the template. Okay, so here's the example. I've got to design a function called area that consumes the length of one side of a square and produces the area of the square. Let's see, so the length is going to be a number, and the area of a square is also going to be a number. So the signature is number to number. And the purpose is given length of one side of square, comma, produce the area of the square. Let me just make a note here about what's not a good purpose. This is not a good purpose. Given number, produce number. That just repeats the signature. So that's not telling me something we don't already know. The purpose needs to tell me something more specific than the signature about exactly what we do with the given number and exactly what the number we produce means. So given the length of one side of the square, it says this is the length of one side of the square. Produce the area of the square. This number is going to be the area of the square. So that's what we want a purpose statement to do, is be quite specific about what's going on. So now let's see, the stub is define area. This is a one argument function, and maybe the length of a side will be s. We can use any name we want, but s seems good. And let's see, this is producing a number, so a good dummy value to produce is 0. Now let's do some check expect. Let's see, check expect area of 3. Well, if one side of the square is 3, then the area is 9. And we'll do another one, check expect area of, let's say, 3.2. And let's see, the area of that square is times 3.2. 3.2, I won't try to do that in my head. Now we run the check expects, and both ran. They failed, but they both ran. So that means they're well formed. We can continue. Now let's see, we've got the stub. Let's comment out the stub and label it. And we'll write the template, area with a parameter s that's a number. The template is ... s. And it's going to be good to have a copy of that template, so I'll make a copy of it right there. We'll comment out the original template. We'll label it as the original. And now let's see. This is a function that consumes the side, and it just multiplies the side by itself. So this becomes times ss. Let's run that. Oh, we got a failing test here. Let's see what's happening. This says that the actual value 9 differs from 3, the expected value, and I can click to see which test it is. Let's see, it said it produced 9, and oh, here's a thing that happens. This test is actually wrong. That's not supposed to be 3. That's supposed to be 9. Now if we run it, both tests pass. So there's two interesting things in this example. One is to note that you need to be careful if you get a failing test to make sure the test is right. If your test is wrong and you make the function conform to it, then the function will be wrong. And that happens. Sometimes you write a test and you're just going a bit too quickly and you put the wrong expected value. So whenever you have a failing test, first look at the test to see if the test is right. The second interesting thing that's happening in this example is to see that sometimes you have to copy part of the template. Remember, the template for this function was ... s. And in the final function, we ended up with s times s. And so we copied a piece of the template, and that's okay. The template is really trying to tell you, hey, here's the stuff you have to work with. You can use it in any way you want. It's just telling you this is the parts list. You can use s twice. So there you go. That's our second function. I'll save it and run it one more time.